in this video, we'll discuss increasing and decreasing functions. In particular, we'll understand how derivatives can help us determine when a function is increasing and when it's decreasing. So we certainly understand when we look at a function what is meant by when the function's increasing and decreasing, whether the function goes up or down. But in calculus, we want to be a bit more precise. In particular, I've written down the definition, the official definition, for when a function is increasing and decreasing. So here's the definition. Suppose f is defined on an interval I. We say that f is increasing on I if f of x2 is bigger than f of x1 whenever x1 and x2 are in I, and x2 is bigger than x1. So it's sort of like what you expect. As we increase in x, if the corresponding output or y values are also increasing, then the function is increasing. And similarly, we say that f is decreasing on I with the same definition. That is, if f of x2 is now less than f of x1 whenever x1 and x2 are in the interval I, and, of course, x2 is bigger than x1. This again means that if we're increasing in x, the corresponding output or y values should be decreasing, going down. Let's look at an example to make sense of this definition. So now I've drawn some examples to help us understand exactly what we mean by the definition of increasing and decreasing functions. So when we look at these functions, we easily know which one's going up and which one's going down. But again, we want to be more precise when using the language of calculus. So clearly you can see here I've drawn two pictures. The function is in red. Clearly the first one, we would all agree that that function is increasing. And the second one, we would all agree the function is decreasing, right? One's going up, one's going down. But again, we want to be a little bit more precise. So notice that I've drawn an interval here, right? Here's an interval of x values. Notice that in each case, x1 is clearly less than x2. And it's drawn on the usual axis here, xy plane. So notice that x1 is less than x2 in both cases. Moreover, look, in the first case, this is clearly increasing, but why exactly is it increasing? Well, look, x1 and x2 are both inside of my interval. There they are, right? They're in the interval, right there. The interval is drawn in brackets, green brackets. Moreover, look, the x1 value, if I plug that into my function, I get a corresponding y value, an output, right? This is really like my f of x1, right? That's equal to y1. And f of x2 here, if I plug x2 in over here, I get a y2, right? Notice that clearly the y2 is above the y1, right? So that means that as I increase in x, my corresponding y values go up, okay? And that's what we mean by increasing. So you can see here by using the terminology we had in the definition, f of x1, the corresponding y value is clearly below the y value of x2, right? In other words, we have something like this, right? Clearly, this y2 is higher than this y1. Well, that's really f of x2, and y1 is f of x1. So that's an increasing function. Moreover, we could all agree this one's decreasing. Why? Well, look, I've drawn a point x1 and a point x2 inside of my interval I, indicated by the green brackets here. They're clearly in the interval. Moreover, here's my y1 and here's my y2. So y1, of course, is my output after I plug x1 into my function. This is f of x1. And my y2 is a y output value, which occurs after I plug x2 into my f value. So this is f of x2 is y2. So you can see y1 is above y2, and I'm increasing in x. So if I'm increasing in x, I should decrease in y. That's exactly what we mean by the definition. So again, x1 is less than x2, but f of x1 is definitely above f of x2, right? The y value is higher. So we have something like this. All right? So each time, keep this in mind, if we increase in x, in increasing function, the corresponding y values will continue to increase. If we increase in x, the corresponding y values will decrease if we have a decreasing function. That's what we mean more precisely by an increasing function and a decreasing function. We also keep track of when a function's increasing and decreasing by the intervals in which it is increasing and decreasing. So in particular, we say that if this is my interval I, clearly this behavior is true for all the points in this interval, not just x1 and x2, but any point that I could possibly choose. Every time I'm increasing in x, I increase in the corresponding y. So this function is increasing on the interval I. Similarly here, no matter what point I choose in the interval I, we can see that this same behavior holds. So that means that the function is decreasing on the interval I. So in particular, we can think of a function which may increase and decrease along different parts of its domain as sort of partitioned into where it is increasing and where it is decreasing. Okay, so if you have the collection of all points for which it's increasing, the function's increasing on that interval I, and the set of all points for which the function is decreasing, again, we say the function is decreasing on that interval I. In particular, a function may increase and decrease over different parts of its domain. And so we'd like to be able to characterize the overall behavior of a function based on whether it's increasing or decreasing. And the way we do that is to look at different pieces of its domain, different x values for which it's increasing and decreasing. So here's an example, right? We can easily see that this function is definitely increasing over this interval, right? From 0 out to this spot right here. It's decreasing from here to here, right? The function's going down. And from here to here, the function's going up for every other x. So in other words, we can take its x values and break them up into little intervals for which the function's increasing and decreasing. Okay, this is going to be something important for calculus. In particular, we can see that here's an interval right here. Maybe I'll call it I1, where the function's increasing. Here's another interval here. I call it interval I2, where the function is definitely decreasing. And I look at another interval here, I3, where the function is again increasing. Okay? So again, we characterize a function by the intervals over which it is increasing and decreasing. That's what we mean by a function is increasing or decreasing. Okay? And you can clearly see that for any x value that I possibly choose in this interval I, the function will be increasing. In other words, it will have the behavior that we want. Right? If x1 is less than x2, then f of x1 should be less than f of x2. Right? The corresponding y values are increasing. And similarly here, any point that I possibly can choose in this interval I2, right, I have that as x increases, the corresponding outputs or y values decrease. Okay? So that's how we characterize increasing and decreasing functions, even if on the same function it's increasing and decreasing. We consider the function increasing or decreasing on intervals.